Oh, oh, my mistake. Oh, man, so many cables. Oh, excellent. Right. Let's start by talking about the future and, in some ways, the past. So, I've updated the schedule. I've assiduously tried to put our lectures on YouTube, but it takes a while, and sometimes I forget about the lectures, so it only appears a day later. But they're all there. None is lost. They're on the schedule now. This is what we're going to do for the rest of the term. We are now here on the 11th of April. Two important things about the future. One is that on Friday, there is a meeting or feedback session for the class representatives. So that's Ronaldo, Craig, and Kat. No, Kat. No. Not Caroline. What? Stephanie. Yeah, Catherine, Stephanie, same name. Yes. Okay, right. So, if you have complaints or compliments, please tell them. Please send them an email or send them a message on Sunday or put something on the WhatsApp group. Has there been any activity on the WhatsApp group? Good. I'll remind you again, tomorrow's start and Friday morning, 8 o'clock. But I'll send you guys an email. It's at 1 o'clock in computer science. And you must please try to be there because it's good. I get extra 10 rand a week if you come. And, say again?
10 rand a week is not bad.
It's big money where I come from. So I'll remind you again, class representatives. Steph, as I call her, and the others, and I will have another meeting towards the end. But you'll all be able to influence my salary, get me fired, or maybe promoted by putting out a course evaluation at the end of the course. But that'll come later. I'll try to somehow induce you. Usually chocolates work, but I'll give you some other kind of inducement to come and please fill out the course evaluation. Maybe not releasing your marks, for example. Okay. Alcohol, yes, but it's a little illegal. Okay. I said there are two things about the future, but actually three. The second thing I want to mention is that your project is due next Thursday. And there won't be tutorials because we'll be marking the project during this tutorial. I'm still trying to get the mentors organized. I have the money, but it's not easy recruiting the students. But I hope that this will turn into a mentor session and that there will be other sessions during the week. And maybe there will be a mentor session in this tutorial also. The project, some people have asked me, a couple of people asked me, it covers all of those requirements. As I said in the tutorial, the R requirements, the T requirements, the M requirements, the S requirements. All of those must be satisfied. So all of the requirements have to work for this midterm submission. And then the requirements will be added for the final submission at the end of the course. Okay. My sidekicks or demis have told me, but mentioned that they've mentioned two things. Firstly, people have posted ads for tutoring, and you are honestly free to make use of them. Just be aware that there are just a couple of scammers. So if you want to hire an outside tutor, just try to find out from other people who've used them if they're okay or not. Because there have been scammers in the past at university, and I don't know what happened to them. They somehow just disappeared one night. They were still found bodies. University has a very strong military department. SWAT team. That takes care of these things. The Davids have also said that there have been posts on something called Face page. Facebook. Yes. Studies confession. You know. What else do you know? That asked for someone to do their project for them.
Oh, yes, I saw that. Oh, sure. I
Yeah.
did some shade on that post.
Well, that student won't be posting again. During a sting operation, we agreed to meet them, exchange the project at midnight by the old oak tree in the church. And they're taken care of. You won't be seeing them in class again, don't worry. I'm also going to make a sting operation to find the people who would answer such an ad and have them pass their exams in a special way. I'm just kidding. We don't kill. The university has never ever killed anybody except a couple of students who died from hard work. But you're not in danger. Don't worry about that. Okay? You're in no danger. So don't copy your project. It's going to be, well, I don't know. I can't say it'll be bad. Maybe it'll be good for you. Maybe you'll go on to a prestigious post in government, be found out, fired, start drinking, using heroin, end up in jail. Okay, fine. Last thing is, I don't know who noticed that it says here test 2 at 6 o'clock on Monday. Say again? It's varsity club. You want to go to varsity? What is varsity club? Oh, cup. Oh, yes. It's a final test during the term time. I call this test the varsity cup test, and the other test will be in exam time. It's just a test. It's not an exam, but it'll be during that time. But unfortunately, this is on the schedule. I don't want to test you, but we'll have to write this test.
Can you make it really easy so we can leave and go watch the rugby?
That's my plan. My plan was to make it really, really easy. An easy, comprehensive, in-depth test of your knowledge and analytical abilities. It'll cover everything we've done until this day, which is why, no, Friday the 13th. Friday the 13th, which is why we're going to have a little recap about everything I've told you about static methods ever. And even though the test will technically only kind of pick up here where it says array functions, it's impossible to avoid things that we've done before, like loops and ifs and all that. So just assume this test will be on everything we've done since the course started. Every word I've said etched into your memory will be in the test. Okay, so I'm not going to give out another sample of the test. It'll be like the previous. Okay, Justin, you okay? You look suspicious and threatened. Mozart. I didn't explicitly talk about it, but that was just the. And I'm not going to ask about that. I'm not going to ask how do you use standard audio. Don't look at the textbook. What is the 4 method calls available from standard audio? But if you want, you can look at it yourself. But that was just a show. I don't want to write Mozart because if people see it, we talk about Mozart. Yes.
We'll also include we did some kind of drawings on one day.
We did the path folder where we plotted all the points in the United States. All the points in the United States we plotted. Yes.
Is that something we need to know how to do?
I'm not asking you to have specific knowledge of the United States or other countries or of how to draw things. I won't ask you, right, pray and I draw something. But there were some principles involved about reading a file from using the scanner and translating those coordinates. So it's just general principles. Now, let me be clear. You must be able to program, but I don't want you don't need to have specific knowledge of plotting standard draw or standard audio. So you don't need to know those libraries specifically. If you can program Java, you can pass the test. If somebody walks in and they know Java and they don't know standard draw and standard audio, they'll be fine. But I don't want to say all you need to know are general principles like what is a for loop, because there's a difference between knowing what a for loop is in theory and actually being able to use a for loop. You understand what I'm saying? What I'm saying is that you must be able to program for loops and other stuff, you know. But you don't need to know the details of standard draw and standard audio. Yes.
Also, for the project, when will the rubric be added? Because just those 25%.
Yes. I don't want to navigate away from the screen because I've modified the HTML to to fit the schedule on the screen. But let's see if I can get back to it. Oh, I can. Okay, fine. Evaluation. This is the rubric. This tells you the kind of questions we're going to ask, and without giving the specific tests, the marks you're going to get for passing those tests. So there will be no more detailed rubric than this. Does that answer your question? Are you slightly disappointed?
Yes.
What did you expect? What do you want? What is a rubric? I can add blocks to this if you want. I can make it a table. It will contain the same information, but it will be in tabular form. I hope you don't think a rubric is like, here is the answers, and if your answers are the same as these answers, you get the marks. So that's the memo. That's not the rubric. The rubric is how are marks assigned and what do you get marks for? How do we mark the assignment, what have you? Okie dokie, right. Anything else that is sensible or substantial? Yes. Oh no. Yes.
The test, will it be set
Test.
the same as the last one?
Yes.
As in most of it being multiple?
Yes.
And will the multiple choice count more than the actual program?
Yeah.
Well, the marks for the
So like
Multiple choice
test
be more
one,
than the marks of the program. Because it was 80% multiple choice and 20%.
Yeah, it was. I don't know what the ratio is. Can't recall the details, but not necessarily. Maybe there'll be more marks for being able to program. Who knows? Okie dokie. Right. Let's talk about what we're supposed to talk about today, which is something you didn't have to read for, but just remember that there's still reading to do, and you really should read those. If you don't understand something in the textbook, you should ask me about it in class. I don't mind looking at the textbook and answering questions. If you don't read, you're missing out on an iteration where you could be learning stuff, and especially if you're struggling, then the reading is essential. Even if you don't understand all of it or some of it, read and ask. We are supposed to talk about unit testing. Who knows what unit testing is? Who can program? Who's done Java programming at school? Did you learn about unit testing? Okay, right. We write programs to solve a problem. How do we know when we're done? When the problem is solved. How do we know that? We have to test our programs on the problem. So testing and programming go hand in hand. We have this edit, compile, execute cycle that we follow, but that cycle could go on forever unless we know when to stop. And the stopping condition for that cycle is, I know I've tested the program and I can see that it works. Okay, fine. So, and actually the cycle is edit, compile, execute, and test. Maybe you can say that execution is the testing. How thoroughly do I test? I can't test all possible inputs. There may be an infinity of inputs. So I can't know that, I can't just say, I'll stop when I've tested all possible inputs. I can't just test one input, because that's too few. If I write a program that's supposed to square the input, and it always outputs 4, and I test it with input 2, then it'll look like it's producing the right answer, because 2 squared is 4. But for any other input, it won't work. Is that true, Justin? Can you think of another input for which it'll work? -2, exactly, right. So, I'm sorry to interrupt your conversation. I apologize. How rude. Okay, right. So, we have to test our programs. How do you test a program? There are many ways. There are many kinds of testing. It's difficult to classify testing, but the two big ways of classifying that we use in computer science is black box and white box testing. With black box testing, the program is a black box. You know what it's supposed to do, you know what the inputs and the outputs are supposed to be, and you get the executable. You get the .class file, but you do not know the source code. You do not know how somebody solved it. So the only thing you can really do is bombard it with different inputs and see that it always produces the right output. It's a black box, you can't see into the program. Sometimes, however, we do white box testing, where you have access to the source code. And that can help you. I can take a piece of source code that I've written in the past, if I can find it. Excellent, our tic-tac-toe board. I can look at the source code and I can check that, have I tested all of it? No. I've tested nothing today. So maybe I should test this routine. So I can write inputs that will test this routine as thoroughly as I can. And then I know I've covered this part of it. And I can move on to the next. So if I have the source code, I can be a little more systematic about what kind of tests I write. In the real world, testing is a big part of making software. And there is usually a quality assurance division in a development group. And those people, all they do all day long is test computer programs. That's their job. All they do is testing. So there's a group of designers who are designing the whole architecture of the software. There are a lot of code monkeys who are writing the actual code. And then they send it to the testers, and they test the code. If there's a mistake, it goes back either to the the programmers who made some kind of low-level mistake, or back to the designers if there's some big flaw in how the whole thing is supposed to work. So the testers are responsible ultimately for putting a stamp on the software saying, okay, now we've tested the software, we are confident that it's 100% correct and we can send it out to the world, we can sell the software. But they're not the only people who are supposed to do testing because they can't do all of it. Individual programmers like you, like me, are also supposed to write their own code, their own tests. And that's usually called a unit test. So a unit test takes one unit of the software I've written, in this case usually a function, like that getMarker function, and I write a test for this unit. In fact, I write many tests for this unit. And especially with libraries, where they may be used by a lot of different clients. That's why they're in a library. I use it often, so I make a library out of it so that I can reuse it later. I have many different things that are going to call this function getMarker, different parts of my source code. So I want this library routine to work, this library unit to work, and therefore I need to unit test it thoroughly. And I want the unit test to be part of my library. So here is the board library. You've seen it before, I hope, or can remember it. I just want to make it a little more exciting by removing all of it. So I'm going to just make a copy of it, which I'll call the board library. Oh, a little joke there. Okay. And adding something that's a little more substantial or testable to it. So I'm going to write a few functions, by a few I mean two, that we can test today, writing unit tests, that we can actually have mistakes in. So I'm going to write a function, public static. What should it do? Let's say it sends back the absolute value. No, there's a more exciting one. Let's do sign. So it's going to send back an integer. The function is called sign, and it accepts one integer value as parameter. And I'm going to write a little documentation. Returns -1 if the value is negative, +1 if the value is positive, and 0 if the value is 0. Okay. Fine, so I'm going to write an if statement here. If value is greater than or equal to 0, else. This is not nice code, I know. But this can't be, so greater than 0 plus 1. Return 0. In fact, this is so ugly. I'm just going to make it nice. Can't make, yeah, fine. We'll do that. Else. Just rewriting it a little bit. Okay. So I may or may not have made a mistake in this. Say again. What? I'm not hearing it. What? Oh, okay. No questions. Right. I'm going to write a unit test to check if my code is correct. I could write a client for this library that will unit test it, but there's a much better way of doing it. This is a library. It's not supposed to do anything on its own. It's supposed to contain a lot of routines that I can call from outside, from other parts of my code. So it has no main. So what I'm going to do is I'm going to add a main to this library. Public static void main string args. And when this library is executed, it is going to unit test itself. It's going to unit test itself. So I'm going to write, well, let's unit test the sign function. I'm going to say use a Java keyword, and something we haven't encountered before, called assert. And assert says, I'm going to make an assertion, and I expect it to be true. And if it is true, then nothing will happen. But if my assertion is false, then this whole program will abort. Okay? So I'm going to assert that the sign of -10 is -1. And I'm going to assert that the sign of +10 is +1, and 0 is 0. Just writing a few asserts. I can write more complicated code where I do some kind of calculation, and at the end I make an assert, or I can assert things in a for loop, all that. Right. Just to make things a little neater, if one of these tests fails, I want a nice little message. So I can add something to an assert. At the end, I can add a string after a colon, which unit test 1, which will be displayed when the assert fails. Not when it passes, but when it fails. So I'm just going to add kind of like names. And also, if none of the asserts fail, I want to write that all tests passed. Okie dokie. So I'm going to compile my library for Java. Okay, let's hope the compiler loads quick. No, it's very true. Too eager. Okay, so let's This is not how it's supposed to work. A library is not supposed to execute by itself. The board library or the player library, whatever library we have, it's just a place where we stash a lot of functions we've written, utility functions. And we have one program that contains a main that executes. So it's not natural to execute a library, but in this case, I'm going to do that. And I expect it to say that all the tests have passed. Excellent. Everybody happy? How come? You didn't expect the test to pass, did you? It does say all the tests passed. Okay, I made a tiny little mistake, which anybody can make. I'm only human. I'm not part monkey, as the rumors have it. Okay, right. When I use these assertions, I have to tell Java to actually switch them on. Normally, assertions are not, they're ignored. They're not evaluated. So unless you give a special flag to Java, it is not going to make those assertions or test them. So I have to give a flag that says enable assertions. Gee, I hope that's right. Board. Oh, okay. And now it actually did try to execute the assertions, and it says unit test 3 failed. There was an assertion error, and the string it reports is unit test 3. So for sign of 0 is not equal to 0. This assertion was false. So what happens? I get a value in here that's 0. Is 0 greater than 0? No. Is 0 greater than 0? No. Else return minus 1. Ooh. And of course, this should have been equal to 0. So there was a mistake in my program. Let's do that. I'm going to recompile it because I've fixed it. I'm going to execute it again, and now all the tests pass. So when I write a function, when I add a function to this library, I'm also going to add unit tests that I can run to make sure that my function works correctly. This is a great idea because it allows me to just concentrate on one little function at a time and make sure it works, and then I can use it in the rest of my system. It would be a stupid idea to add 20 functions and then kind of be lazy and see, am I going to write unit tests for them or not? Probably not, because I'm in a hurry, only a few hours before the deadline expires, and I'm just going to use the functions without knowing that they're correct. It's so easy to make a mistake, and it's hard to be disciplined and say, whenever I write a function, I'm going to add corresponding unit tests. But in the long run, it actually saves time and it saves effort. Sometimes unit tests can be a little bit tricky. So, for example, let's put back some of the original idea of board. We used to have a tic-tac-toe board, but I'm going to change that. I'm going to change it into a one-dimensional board. What kind of game has one-dimensional board? What? That is not strictly true, is it?
I suppose you could kind of branch off.
At 6 and 7, 8 is 1. No, 5 and 6, 8, 7, 8 and 9, 10. Let's just pretend there is a very yes. Oh yes.
Snakes and ladders is a single array.
How dare you? Snakes and ladders. No, well, you can think of chess as a single board, or tic-tac-toe as a long board that's been wrapped around. Let's just pretend there's some mythical game that we have that uses the board. Okay, public, static, void, initial, init, in size. I'm going to write a routine that's supposed to initialize the board. And it's going to say board is a new board of size. And for int I, 0, up to the size, I'm going to insert a value of 99 inside the board. Cool. Right, new routine. Initialize the board and fill with 99s. Fine, I've written a piece of comment. I'm going to write my unit tests. So now I've got to think a little bit. Is it a good idea to write assert board is null? Well, when this program starts executing, board has no value. It's not been initialized because I'm just executing this file. So it is probably true that board is null. I've told Java I want an array of integers that's one-dimensional called board, but that doesn't mean the array exists. Board is just pointing somewhere, and initially it's pointing nowhere. So its value is null. Maybe you haven't seen that before. But I want to add it, so I'll add that. And then I'm going to call initialize for, and now I'm going to make more assertions. Board is not null. Board's length is equal to 4. Board 0 is equal to 99. Board 1, well, I can just as well write a for loop I, 0, I less than 4, I plus plus. In fact, if there is a mistake in board, it's just going to print unit test 7 failed. So there's a mistake in the contents. So I'm going to kind of like add here plus I. So, okay. Is everybody happy with this, or are there some big complaints that you want to tell the class representatives about? Okay. Everybody's happy. So let's see if our code is correct. We recompile, execute. Oh, ooh. Unit test, what do you want? What's the complaint? Yes, what is the complaint?
He says you're too hot, you can't focus.
I'm too hot. I am disgusted by your poor taste. Okay, fine. It says unit test 7, board I is 99, but it's not for I equals 0. Didn't I initialize I equals 0? No, I hope that surreptitiously, without any of you spotting it, but probably half of you did, I changed this 0 to a 1. So I'm going to change it back to a 0, and I'm going to recompile. Okay, and now all tests pass. So, truth of the matter is, I absolutely never, ever, ever write unit tests like this. Because Java has a special library that you can add to it called JUnit, which allows you to write your unit tests in a slightly different way, so that you don't contaminate the library at all. I mean, the advantage of this is that wherever board goes, wherever my code goes, there is now unit testing built into it. If somebody just executes board, it'll be executing unit tests. And that's a great feature, but if this was a real library that I've written for NASA and it's going up in a satellite, they probably don't want 10K of real code and 500K of testing code. So in many situations, it is somewhat sensible to split the implementation of a library from the testing of a library. An implementation is a specific implementation, and I could in fact have many different implementations of board, and they all need to have this exact same testing code. What I'm testing down here is not the specific implementation, but the requirements that I have for the board library. So it's what do I expect of board? How should it behave? This is what these unit tests are testing. And to couple them to one implementation is probably a bad idea. So there are pros and cons of adding unit tests into a library like this. And when I write unit tests, I write them in a separate file, and I'm using this JUnit library, and it just makes life a lot easier. I'll show you on Friday. Now I'm going to stop, because I promised some people that I'll answer some of the questions afterwards. Tomorrow start, come if you can, if you're scheduled for Thursdays, because we are going to look at Eclipse like we did yesterday. Who was it yesterday, Stat? Who had not been using Eclipse before? Who has actually used it now, at least a few seconds during the TAT? Okay. Who plans to use it in the future? Okay. So Eclipse will change our lives, honestly. Even if it looks a little daunting, and I'll introduce that at tomorrow's TAT for the Thursday group. Tomorrow we have a TAT. Friday we have our last class, and on Monday we write this test. So last class before the test. And then project is due next Thursday, and I'm supposed to organize these mentor sessions. Also Friday we've got the class reps. So please send them complaints or anything else you want. Okay, thanks guys. I'm going to stop now.